The time has come, October 29, 2025, the moment astronomers have been waiting for months. Today, the interstellar comet 3I Atlas reaches perihelion, its closest approach to the Sun, which is just 1.36 astronomical units away. A visitor from another star system is now diving into the heart of ours. And what it does next could change everything. Scientists and space agencies across the globe are intently watching this moment. Will it flare up or change in some unexpected way as it touches the Sun's warmth? Could it even reveal signs of something not natural? Let's find out. As of today, 3I Atlas is just 1.36 astronomical units from the Sun, roughly 203 million kilometers, a position just inside Mars's orbit. It's currently on a hyperbolic path, meaning the Sun cannot capture it. It's here briefly, and then it's gone forever. Earlier this month, on October 3, the comet made its closest pass to Mars, just 28 million kilometers away. Astronomers used this window to gather what data they could before it disappeared into the solar glare. The European Space Agency even reoriented its orbiters around Mars to snap rare images and measure gas compositions during this close pass. From here, it begins its outward journey. In early November, it will come relatively close to Venus. By March 2026, it will be nearing Jupiter's orbital path. And then it's gone, lost to the void of interstellar space. But what makes 3I Atlas so unusual is its trajectory. It's nearly aligned with the ecliptic, the plane in which all our planets orbit. That's rare. Most interstellar objects approach from odd angles. This one is slicing right through the planetary highway. The odds of such alignment, according to Loeb, just 0.2%. Even stranger, its closest approach to the Sun occurs when Earth is unable to observe it, hidden behind the Sun in what's known as solar conjunction. From Earth's perspective, 3I Atlas vanished from view around October 21. Now, at perihelion, it's still cloaked in sunlight's blinding brilliance. That means Earth-based telescopes are essentially blind to this moment. A cosmic coincidence? Possibly, or perhaps a perfect cover for something more mysterious. After months of buildup, 3I Atlas is making its closest sweep past the Sun. There's a bit of a calm before the storm feeling. Due to the Sun's blinding presence, direct observations from Earth are paused, but scientists are eagerly awaiting data from any assets that can observe. Will 3I Atlas brighten or erupt as many comets do when they reach peak heating? Already, in the days leading up, the comet's total brightness was increasing. Some models suggested it could undergo an outburst, perhaps sudden jets or even fragmentation, as heat stresses the nucleus. If a breakup occurred, it would likely be detected by a sudden surge in brightness, or later by the appearance of multiple fragments. As of now, there's no report of a breakup, but comet experts are definitely watching for any hint of one because large comets have been known to split near perihelion. There's also the question, after perihelion, will 3I Atlas emerge looking different? Comets can drastically change. New tails can form, old jets can shut off, the color can alter. By early November, as it becomes observable in the morning sky, a lot of telescopes will be aimed to conduct a post-perihelion health check on 3I Atlas. Global interest in this event is intense. Space agencies will likely release updates. NASA might share Hubble or JWST observations comparison pre- and post-sun passage. ESA will eventually publish the Mars images and any results. The IAWN campaign starting next month means dozens of observatories will swarm it with observations, ensuring no weird motion goes unnoticed. If, and this is a big if, 3I Atlas were to do something like change course in a way that gravity and normal outgassing can't explain, it would set off alarm bells and instantly elevate the alien craft theory. But so far, its trajectory has followed the expected gravitational path. In fact, the latest orbit solutions are very precise. By March 2026, when it's near Jupiter, the position uncertainty is only on the order of 100,000 kilometers, which shows how well astronomers think they understand its motion. Still, everyone is watching closely right now. As one scientist put it, these interstellar objects are like cosmic time capsules. They carry messages from distant places in the universe. 3I Atlas's message could be entirely geological, telling us about chemical conditions around another star long ago. Or, just maybe, it could be an intentional message or even messenger from another intelligence. The vast majority of scientists lean toward the former, but they are nonetheless extremely keen to hear whatever this object has to tell us. So, as our interstellar visitor rounds the sun today, there is a palpable sense of drama and wonder in the air. It's like the climax of a sci-fi documentary, except it's real data coming in. We have front row seats to an event that is both scientifically profound and, admittedly, a little spine-tingling in its mystery. Whether 3I Atlas is a comet or a craft, it is absolutely unique. Never before have we had such a detailed, up-close study of something that came from another star. The world's top observatories are on high alert. Researchers are pulling all-nighters to catch every bit of information. The seriousness of this object's uniqueness cannot be overstated. As Avid Loeb wrote, even if it's 99% likely just a comet, we owe it to ourselves to check that 1% possibility, because the implications would be staggering. And if it turns out to be natural, we still win, because we'll have learned something new about our galaxy. This is a win-win moment for science and human curiosity. Will 3I Atlas quietly continue on its way, leaving us with answers about its natural origin? It very likely will, and that alone will be one of the great scientific stories of the decade. When 3I Atlas was first spotted in July by the Atlas survey in Chile, it appeared faint, just a smudge of light, but over the following weeks, its activity began to rise in ways that didn't match typical comets. At first, astronomers detected a bizarre sunward-facing jet, a plume of gas and dust pointing directly toward the sun. That's the opposite of what we expect. Comet tails normally stream away from the sun, pushed by solar radiation and wind. Some scientists thought it might be an anti-tail, a known optical illusion caused by the angle of observation. But further analysis showed it was real. Then, in mid-September, just before perihelion, the comet's behavior changed again. The sunward jet faded. A traditional tail emerged, pointing away from the sun, stretching out tens of thousands of kilometers. The transition was sharp. Natural explanation? Maybe, but the timing was uncanny. To those with open minds, it looked like something had turned off the engines. By the end of September, the comet displayed a more standard appearance, a coma, a tail, and increasing brightness. Yet what lay inside that coma was even more perplexing than its shape. NASA's James Webb Space Telescope got an early look in August. It scanned the coma of 3I Atlas in infrared, revealing an astonishing chemical signature. Most comets begin to vent water vapor as they approach the sun, but 3I Atlas wasn't dominated by water. It was exhaling carbon dioxide, massive amounts of it, along with carbon monoxide and other exotic molecules. One team referred to it as a CO2 fog. Water was a minority component, making up just around 4% of the comet's gaseous emissions. That's unheard of. The composition suggests 3I Atlas formed in a frigid environment, colder than the outer edges of our solar system, or it's being sealed by a crust that traps water inside. But that's not all. The most eyebrow-raising discovery came from the Very Large Telescope in Chile, which detected vaporized nickel without the usual accompanying iron. In most comets, nickel and iron are found together, but in 3I Atlas, iron was nearly absent. Some scientists believe the nickel is escaping in the form of nickel tetracarbonyl, a toxic, volatile molecule rarely discussed outside of chemical engineering. Avid Loeb believes 3I Atlas may not be entirely natural. He cites the orbital alignment, the comet's timing during solar conjunction, the anti-tail behavior that mimics engine thrust, and the chemical emissions as a cluster of improbabilities. Each on its own might be explainable, but together, Loeb calculates the odds of all these traits occurring naturally at roughly 1 in 10 quadrillion. To him, it feels orchestrated. He even speculates the object could deploy smaller probes during perihelion, using the sun's gravitational field for a maneuver similar to an O-Earth burn. His team at the Galileo project is watching closely, monitoring Earth's skies in case smaller objects appear in the weeks after perihelion. Mainstream scientists remain skeptical, and rightly so. Most data points toward 3I Atlas being a strange but natural comet, possibly the oldest ever observed, perhaps formed 7 billion years ago in a cold, metal-rich exoplanetary disk. But Loeb's point stands. Unless we examine the data thoroughly, we'll never know. The price of ignoring the possibility could be missing the most important discovery in human history. The global science community hasn't wasted a second. NASA's Hubble and Swift telescopes observed the comet before it slipped behind the sun. The European Space Agency redirected its Mars orbiters to snap images and gather spectra. ESA's JUICE spacecraft, en route to Jupiter, will scan 3I Atlas from afar in the coming months. Even Earth's newest powerhouse, the Vera Rubin Observatory, caught early images. And the International Asteroid Warning Network has designated 3I Atlas as a planetary defense tracking target, practicing precision observations in case of future threats. This object, from beyond our solar system, is being studied with every tool available: space telescopes, Mars orbiters, amateur backyard systems, and deep sky observatories across the planet. Because no one wants to miss what happens next. Thank you for joining this journey, and if you want to stay ahead of the biggest discoveries and the strangest anomalies in our universe, make sure you hit that subscribe button right now. Turn on notifications so you never miss a moment when the cosmos decides to surprise us again. The next object might be even stranger. Stay curious, stay watching, and as always, keep looking up.